Well, I guess we could take a break for maybe 3 minutes, because we took a little bit of a break earlier. And then just like before, just
my reason.
your reason,
Okay.
and then the answer from my slide, the correct answer.
That's your answer right there.
Yeah.
And that was mine.
So just each one of them has 4 parts. It's your answer, and then your explanation,
Right.
and then my answer and my explanation.
Okay. Thanks.
Are you ready?
How you doing today?
I'm good. How are you?
Okay.
I have a question with that one because it's basically self-explanatory.
It,
Yeah, I don't know if I get it.
you weren't sure what to say?
Yeah, so.
You could just say,
I'm not sure whether it's, I don't even know. I don't know how to explain it with my answer.
you could say that the 2,000 surveyed, you could say that the 2,000 students are, that they're a part of the population that provides data.
Oh, okay.
And then say that the 12,000,
is the population,
the complete group.
the complete group of
Yeah.
the population. Okay.
Yeah.
Okay, that makes more sense.
I don't know if you went over this already, but will you be having the assignment, this week's assignment up for the homework?
Yeah, I already uploaded it actually.
Okay. Under homework assignments?
Yeah.
Okay. I'm only seeing assignment 1 on mine.
I'll check it right now.
Thank you.
Hey, Jerry, have you checked
Oh,
out the
yeah.
student lounge?
Mm-hmm.
It looks pretty comfortable.
Yeah, sometimes it's.
Thought I did.
When I have like breaks, or when I come in so early, I need.
They didn't have it when I first came in.
Really?
Yeah, which is something.
I know it's more comfy, huh, than being in the class.
Definitely, they have couches and
Mhm.
no lags.
Yeah.
So I guess it didn't upload,
It's so
but I'll talk
quiet.
about it
I
in
know
the
there's
class.
no
Okay,
student that
thank
goes
you.
there. When I go there, I'm like basically by myself, so I'm like, interesting, man.
Is anyone still working on this?
You know what would make the room even more perfect? It's like classical music.
I know.
So this is the new question, right?
Mhm.
Okay. Let me get the explanation.
Yeah. Well, the 2,000 people, they're, are the 2,000 people just a piece of the population? Or they're not the whole population?
No.
So you can say the 2,000 people aren't the whole population. They're just the recruited people.
I overheard. You said you've been here for only 5 years.
I'm sorry?
So you've been here for only 5 years.
Yeah.
Oh, that's interesting.
Really?
Yeah, for.
Just say that they're the
For a
recruited
couple of
volunteers.
towns who are like being
Or selected volunteers.
The accent is really strong.
Mhm.
So you're pretty, good so far. It's hard to tell. Yeah, I mean, I can see it, but it seems like it's longer than that. Do you speak English fluently, or did you learn it from your country?
It's,
They sent you to school here?
I'm sorry?
Did your family send you to school here?
It's, I'm just trying to figure out where to start. It's a really long story. It's actually really funny because prior to coming to America, I used to speak with a British accent.
Really?
Yeah.
Wow.
And being here for 5 years, just I lost it completely.
You lost it completely. Wow.
Oh,
That's why you can still hear I pronounce the vowels really strongly.
Mhm.
Then
So why with the British accent?
I'd studied at an institute called the British Council for about 4 years.
In Vietnam?
Yeah.
One thing that's-
Before that, I just.
I was thinking, one thing the
language
person might think when they
institutes.
hear the definitions of population and sample
My
is
accent's actually
a population is a complete group of people that has something in common.
Mhm.
And a person might
Yeah, I
think,
can
well,
tell.
the 200 people, the 200 iPhone users who were recruited to take a survey, they're also a complete group that has something in common. But the idea is, even though the 200 iPhone users who were recruited into the study are a group that has something in common, they're not the entire group that the study is focusing on, because the entire group that the researcher cares about is all iPhone users, and those 200 people are just a piece of that group that the researcher cares about. So the 200 people are called the sample because they're not the entire group that the researcher cares about. Does that make sense? They're not the entire group that's being studied, or they're not the entire group that the researcher wants to make a conclusion about. If you want to make a conclusion about all iPhone users, then the 200 people are just a piece of that group that you're interested in. I'll just give you a couple of minutes to copy this down. So yeah, just copy all of this down under your first answer and the sentence that you wrote out under your answer. So each of these in-class questions has 4 parts to it. And write out my answer even if it's, write out my answer up here even if it's the same as your answer. So you just write B and then B again. So next I was going to get to that slide about the Costco samples. So the reason why they give you a sample of food is to try to help you learn something about the entire product that it comes from. So if one of the demonstrators takes out a package of some type of food and gives you a sample of it, the entire package would be a population of food, and the sample that you're tasting, the piece that you're tasting would be a sample. And I think it's a good analogy because when you do a study, you have a population of people, and the participants that you select from the population are the ones that you get information from, meaning the ones you record data from. In the same way, the sample, when a person takes a product or a package of food and gives you a sample of it, the sample is the small piece of food that you're getting information from by tasting it. So the sample is the piece that you're tasting and getting information from to try to help you learn about the entire package that it comes from.
Because that's what they do at Costco before
Yeah.
you buy the product. That way to see if you like it or not.
Yeah.
Or like Trader Joe's or something.
They're trying to convince you that the population is good enough to buy.
Mhm.
The package of food is good enough to buy.
But then they would want us to jump to that one solid conclusion.
Yeah, but it's a little bit different than studying people because if a person takes a package of food and cuts it up into little samples,
Mhm.
each sample is pretty much the same usually,
Yeah.
and they all pretty much tell you what the product tastes like. But if you take a population of people and divide it into samples, each sample is a little bit different. So it's not exactly the same.
That's why when they do studies, they do random sampling sometimes. And
Yeah.
How about like for longitudinal study?
Where you do the same sample, right?
Like, because
Well,
you
that's-
have to stick with the same
Same
sample,
group, right?
Same group
Right.
of population.
So in a longitudinal study, you find a group of maybe, let's say you're studying adolescents, you might start with a group of 12-year-olds and then collect information from them and then wait 3 years until they all turn 15 and then survey them again and then wait until they're 18 and then get information again. So you're recycling the same group of people over and over,
The same sample.
the same samples. You're trying to see how a sample of people changes across time. But then the purpose of that, remember, you care about the entire population. So what you're really trying to do is you're trying to see how the entire population is changing across time using the sample. So if I collect data from 12-year-olds and then collect data when they're 15 and then when they're 18, I'm trying to get an idea of how people in general change from 12 to 15 to 18.
What happens if the number of the original participants change? Like it's the same group, but then few people
If they drop
Yeah.
out. That happens a lot. It's usually not a problem if not too many people drop out. But if a person drops out, then a lot of the time you'll have to discard all of their information.
Because you can only compare the same people.
Yeah. So if I start with a group of 12-year-olds and I start with 100 12-year-olds and then one of them drops out, pretty much that one person who dropped out, I only got one observation of them at 12 years old, so I have nothing to compare it to. So their information is pretty much useless.
Oh. But if
You
it's
can't-
like a lot of them, then you have to, would that change? For example, like if it's a lot of them dropped out. from
Well,
the
if a lot of them
collection.
drop out, then you have some problems because then you're wondering, if you see a difference between time 1 and time 2, then it becomes unclear whether you're seeing an effect of time, or if you're seeing an effect of people dropping out, it becomes two possible explanations. Does that make sense?
Yeah.
When that happens a lot, sometimes that happens if you're studying some type of intervention or some type of training program, where if a lot of, maybe I'm studying some type of training program, and I start with people at time 1, and they do poorly, and then I give them the treatment, and then at time 2, their performance is a lot better, and then I think the treatment must work because now they're doing better at time 2. But if a lot of people ended up dropping out between time 1 and time 2, like if a lot of people said, I don't like this program, so I'm dropping out of the program, what could have happened is the people who had the people who would have had poor performance, or the people who were struggling, are more likely to drop out. And those are the people that would have dragged down the time 2 average. And since they're not there anymore, since only the strong people are left at time 2, it looks like time 2 has really good performance. But then you wonder, is it because the treatment is really effective, or is it because only the good people are left behind and all of the weaker people are gone because they didn't want to complete the treatment?
Makes sense.
Yeah. So we'll skip these. I talked about sample size. The purpose of collecting data from a sample to learn about a population, well, that's what the purpose of it is, and it's called statistical inference. The process of using data from a sample to reach a conclusion about an entire population. And the reason why the word inference is used is because it's not a proven conclusion. You can't absolutely prove something about a sample. Really nice. You can't use data from a sample to absolutely prove something about a population. If you use data from a sample and make a conclusion about a bigger population, there's always a risk of making a wrong conclusion. The only way to actually prove something about a population is to collect data from every member. That's the only way to prove something. Like I said, if I collect the GPAs of 1,000 college students, and my data looks really good, and it looks like college students are doing very well, my data shows evidence that that's true, but it doesn't prove that that's true. The only way I could prove that the only way that I could prove that the average of all college students is a good average, meaning a high average, is by actually recording the GPAs of all 20 million people and averaging them. Does that make sense?
Yeah.
Because what happens if I record the GPAs of 1,000 college students and I calculate the average of those students? What could happen is those 1,000 people could be below average or above average, and I don't know which is the case. So that I'm not actually proving exactly how well college students are doing in general, unless I collect data from every member of the population. So it's oh yeah?
During the first lesson, you said that an inference is not exactly a conclusion, so is it still okay to use the terms interchangeably?
Inference and conclusion?
Yes.
You can, but it's a little bit loose, I guess. It's not, you're not using the terms maybe exactly correctly, but it's, I guess in practice they're probably switched around a lot, and you could use either one.
Thank you.
Oh, you're welcome. So what I'm basically meaning when I say it's not a proven conclusion is that when you take a sample and you calculate some type of value like an average or a percentage, that there's no guarantee that that average or percentage perfectly matches up with the population average. They're not exactly the same necessarily. So if my 1,000 college students have an average GPA of 3.5, that doesn't prove that the entire population has an average of 3.5 exactly. But if I collected data from every member of the population and actually calculated the population average, and it does come out to 3.5, well then I've proven that that's the case. So here's two examples of statistical inference. It's sort of like if I ask each student in this class, if you feel like you have too much homework during the week, and let's say 90% of you say that you have too much homework, if that happens, I can make an inference that JFK students have too much homework. I can make an inference about the entire population, but I can't say because 90% of you said you have too much homework that I've proven that 90% of the JFK population exactly feels that way. Does that make sense?
Yeah.
I haven't proven that I can't say that the percentage of you who say you have too much homework proves something about the entire population.
Yeah.
It only shows evidence. Because it could be, even if 90% of you say you have too much homework, it could be that across the entire population, only 50% feels they have too much homework. Maybe it's not the same percentage. So there's no guarantee that. So these are two examples that I've already talked about. Using a mean means average, right? Using a sample average to estimate a population average. My JFK example would be the second one. Using the percentage of my sample in this class to estimate a percentage of JFK students who say that they have too much homework. And the main point is that it's not a perfect estimation, it's only a rough estimation. That's why it's called an inference. So, but you can usually get fairly accurate information about a population with a sample, but you never get perfectly accurate information. But there are things that you can do to increase the likelihood of getting more accurate information about the population. We'll talk about those things, but still there's no guarantee that the sample will give you highly accurate information about the entire population. The reason is because the sample might be unusual. It could be, if 90% of you say that you have too much homework, that might suggest that JFK students in general feel that way. But it could be that this class is unusual in some way, and for some reason you feel like you have too much homework. But if you know what I mean, if this class is unusual, I can't use you to make a conclusion about the entire population.
Is what you're trying to say is that a class can be considered a population of its own?
It can be. Well, that's a good point. This class here, it depends on what I'm interested in learning about. If all I'm interested in learning about is this class, and I'm not really interested in any other JFK students, then this class would be my population. because you're all I care about. But if I'm really interested in the entire university, and I'm using this class as a way to learn about the entire university, then in that case, this class would be a sample.
Mm-hmm.
Yeah.
Yeah.
So really, does that make sense?
Yeah.
Okay. So, we won't do that one. One thing that matters is the sample size. Larger samples tend to give you more accurate information than smaller samples, because a larger sample is closer to actually being the population. Also, larger samples tend to include a wider variety of population members. That's why you get better information. So, if I'm trying to estimate the average GPA of all college students in the U.S., meaning the population average, I'm better off using a large sample than a small sample.
Mm-hmm.
If I take 10 college students to be my participants, and I calculate the average of those 10 people, I'm pretty likely it's to have an estimation that's way too high, meaning overestimating the population average, or way underestimating. Because my 10 people could be unusual. It could be really high GPAs or really low GPAs. So I'm not getting accurate information about my population. But if I take 50,000 college students and I record their GPAs, now I'm much less likely to overestimate or to underestimate. I mean, I'm still going to overestimate or underestimate a little bit. It won't be perfect, but I just probably won't dramatically overestimate or dramatically underestimate.
Because it has a larger sample.
Yeah. So with a small sample, you're more likely to dramatically overestimate way too high or to underestimate way too low. But with a larger sample, it's less of a problem, and you're more likely to just be slightly off your target, meaning a little bit too high or a little bit too low. So when you have a bigger sample, you get a more accurate estimation of what you're trying to estimate. Does that make sense?
Yeah.
Mm-hmm.
Because if I ask 10 people for their GPAs, I might easily end up with 7 A students in my sample. And if that happened, then if 7 out of the 10 people that I surveyed are all A students, now I'm suddenly thinking, wow, college students are doing very well. But that my small sample is probably misleading me. But if I recruit 50,000 people, I'm probably not going to end up with 40. If I recruit 50,000 people, it's probably not going to be 45,000 A students in my sample. It's going to be more balanced with some A students, some Bs, some Cs. It'll be more variety with a larger sample. So I'll get better information that way. It's the same logic as if I flip a coin 10 times, I'm likely to get a lot of heads or a lot of tails. I mean, it could happen pretty easily. But if I flip a coin 10,000 times, I'm probably not going to get all heads or all tails. It'll be more balanced. So yeah, larger samples mean more variety of population members and better information about the population. some of these questions I'm just going to let you read on your own, because I'll later on I'll upload this PowerPoint with all the questions and answers in it. So we won't use every question that's in here. So I said your larger samples are better than smaller samples. If you want another food analogy, imagine if you're at Costco and you're sampling a product, maybe it's a package of pasta, and someone gives you a sample at the end of a toothpick and says, "This is your sample, and now taste it." Well, what if that toothpick picks up on a hot pepper and makes you think that the product is a lot spicier than it really is? So that toothpick could pick up on a really unusual part of the product, meaning it could pick up on one little piece of pepper that's really spicy, and it might mislead you into thinking that the product is a lot spicier than it really is. But that's a small sample. If someone gives you half of the package and lets you eat half of the product, now you're going to get a very good idea of what the product tastes like. So a smaller sample is more likely to give you a really unusual outcome that's going to mislead you, but a larger sample will give you more accurate information. So also, there's two different types of sampling methods. Probability and non-probability sampling. Probability sampling is when people are selected randomly and all population members have an equal chance of being selected. And the way that it has to be done is with some type of lottery system, meaning one way to do it is to just write each person's name on a hat. Write each person's name on a piece of paper, put them into a hat, and shake it up. And if you take out names without looking, that's a random sample. And if I do that, every person has an equal chance of being selected, as long as I shook up the hat well enough. I could also use a computer program. They have computer programs that can generate random phone numbers. So what people often do when they do telephone surveys is that they'll have a computer generate a bunch of random phone numbers, and then those phone numbers are dialed, and then those people get the survey. And the idea is that everyone will have an equal chance of being selected. But the truth is that if you do that, it's really every person who has a phone has an equal chance of being selected. People who don't have a phone can't be selected. So nothing is perfect. It would still be considered random sampling because it's still pretty random, but it's technically not completely perfect if people without phones can't be contacted. Simple random and stratified random. We won't really talk about the difference between those. This one is a little bit more complicated than this one, but they're similar. What stratified random sampling really means is that you're dividing the population up into subtypes. Let's say I have a population of college students. And I say, let's say I really want to make sure I have an equal number of each grade level. I want to make sure I have the same number of freshmen, sophomores, juniors, and seniors. What I could do is, these are the grade levels. What I could do is take a series of random samples, meaning first I randomly select 50 freshmen, then I move on and I randomly select 50 sophomores, then 50 juniors, then I recruit 50 seniors. So it's really 4 different random samples. And it makes it so I get an equal number of each one. It's called stratified random sampling. Because each one of these is like, you know when they talk about rocks, how they talk about strata, like layers of rocks?
Mm-hmm.
It's like these are the strata of your population, and you're taking a sample of each one. What simple random sampling would be is just a one-step process, meaning if I want, let's say I want 200 college students, and all I do is just, I reach in one time, and I take 200 students, and I just get whatever I get. That's simple random. It's just a one-step draw of all my participants all at once. And if I do simple random sampling, I'm not guaranteed to get an equal number of each one. So simple random is just a one-step process. In stratified random, you're taking a series of different random samples. Like, what if let's say I want 100 men and 100 women. If I take a random sample of 100 of one gender first and then 100 of the other, that's stratified. Non-probability sampling means non-random. Not every person has an equal chance of being selected. One of the most common ones is called convenience. Oh, first I wanted to say that random sampling or probability sampling has to have some type of a lottery system, because I think if you ask a person what it means to do random sampling, a lot of the time a person might say, well, I think that random sampling would just be going up to random people and asking them to take a survey. But that's not really random. Meaning, if I wanted to give out a survey to JFK students, and I just randomly went up to people in the hallways, that wouldn't really be random sampling, because not every person has an equal chance of being selected. I'm probably going to go up to people who seem more approachable or more willing to take the survey, and people who seem a little bit less approachable, I might avoid them. Also, what if I'm in a 3-story building? If I don't really like climbing stairs, then the people at the 3rd floor probably aren't going to be selected. They don't have a fair chance. So if I just randomly go up to people in public, it seems random, but it's really not random.
Is there another name for that?
It would probably be called convenience. Convenient sampling is when you select the people that are easiest to reach. So if I wanted to get to if I needed a sample of JFK students, and I decided that this class would and if I decided that you guys would all be my sample, that would be an example of convenience. The reason is because it would be convenient for me.
Right.
I wouldn't have to put out much effort into finding people. Have you ever heard of something called a subject pool? If you go to a university that does a lot of psychology research, the students who are taking general psychology, usually freshmen, are required to participate in studies that are going on at the university as part of their class requirements. and they're called a subject pool. And if you go into a hallway near a psychology department, you'll see a board with a bunch of sign-up sheets, and it'll say, each sign-up sheet will say, study on jealousy, or study on attraction, and what each student does, each freshman, they go up to the board and they find the study that looks interesting to them, and then they sign up for it, and then they become a participant. And that's an example of convenience, because if I'm a professor or a graduate student who needs participants, that's a really convenient way for me to get people. So that would also be convenience. And the reason why subject pools are used is not because it's necessarily a good way to find volunteers, or not necessarily because it's a good way of sampling. It's really done because it's hard to find people outside of the university who want to participate, or people who are outside of the university usually don't want to participate, or they don't have time. So you have to use the freshmen as your participants a lot of the time. Quota sampling is similar to convenience. It's really similar, but what quota sampling is when you do convenient sampling, but you have a goal of getting a certain number of each type of person. So what if I said that this class would be a convenient sample, right?
Yeah.
Mm-hmm.
What if I decided that I had a quota, meaning I want, in my sample of JFK students, I know I want 3 men and 3 women. So I say, I'm going to take 3 men and 3 women from this class. It's still convenient sampling, but it's called quota sampling because I have a quota of men and a quota of women that I want to meet. It's not, quota sampling isn't random sampling because you're not doing some type of lottery or random drawing. You're just doing convenient sampling, but with a set quota of different types of people. Snowball sampling is an example. That's where sometimes a researcher will be studying a really rare group of people, and it'll be really hard to find participants. So what you can do is maybe, if I'm studying people who have a really rare condition, what I could do is find one person who has that condition, get them to participate, and then I'll tell that person, try to contact all of your friends who have the same, first I'll ask them, do you have any friends who have the same condition that you do? And if you do, could you please contact them and recruit them into the study? And then once all of the friends or all of those people come into the study, now I take my whole group of people that I have and I say, each of you, I'd like to ask each of you to please go out and find more participants for me.
Mm-hmm.
So it kind of rolls downhill like a snowball, and more people get recruited. Has anyone heard of a pyramid scheme?
Mm-hmm.
Where you find people and then they find people,
Yeah.
and then they find people?
Yeah.
That's snowball sampling. It works like a pyramid.
They got a new one. What is it? Prosper with integrity.
Yeah.
It's the same, basically the same thing.
I think in my notes I said something about if you want people who own wild animals as pets, I could find one person who owns a wild animal and say, I want you to go out and contact all of your friends who own wild animals and bring them to me. And once those people come to me, I say, now I want all of you to contact your friends who own wild animals and bring them in. And it's like I said, with snowball sampling, it's not every person has an equal chance of being selected. The reason is because when you're doing snowball sampling, you're recruiting people from a certain network, like a social network of people who know each other, and anyone who's outside of that network won't be contacted. They don't have a good chance of being selected. So just like how large samples are better than small samples, random sampling tends to be better than non-random sampling. Random sampling tends to give you a wider variety of population members and gives you more accurate information. So it's the same thing we talked about with small and large samples. The problem so I said non-probability sampling doesn't give you much variety, and random sampling gives you more variety of people. I said how convenient sampling is an example of non-random. What happens when you use convenient sampling, which isn't random, is you're taking people from one convenient location, such as a classroom, right? And people who are at the same location tend to be similar. So if I use this class as a convenient sample of the university, my sample will pretty much be all psychology majors and probably all juniors and seniors. So by using you as a convenient sample, I'm not getting much variety in my sample. I'm not getting law students or business students. So non-random sampling, meaning convenience, doesn't give you much variety, and it doesn't really give you much, it doesn't really give you accurate information about your entire population. But when you select people randomly, such as with a random drawing, you get more variety. If I wrote out the name of every JFK student and put all the names into a hat and shook it up, and I took out some names, I probably wouldn't get all psychology students like I would in here. I would get more variety. So I said convenience. This class would be convenience. One example I talk about a lot is, or that I use sometimes, is if a person works in the library, let's say a person works in the library and that person wants to, like at the JFK library here, or at any university, and they want to know how much studying students usually do each week. Well, what if that person at the who works at the library says, I'm gonna just give out my survey to people who study at the library because that's convenient. So that person goes around to people in the library and says, please tell me how many hours of studying you do per week. And then what if the results come in and it looks like, what if the results show that students are doing a lot of studying? Well, that would be a problem because by using a convenient sample of students who study at the library, you're probably getting an unusual sample. You're probably getting people at the library probably do more studying than people who don't go to the library. Mm-hmm. So if I just limit my sample to people at the library, I'm probably going to overestimate the amount of studying people are doing at the university. So that would be a problem with convenient sampling. Another example could be, what if A physical education professor was interested in how much exercising the students at the university were doing per week. And the professor says, I'm going to give out my survey to my physical education students and ask them how much exercising they're doing per week. Well, when the results come in, when the results come back, it'll probably look like that the students are exercising a lot. But the problem is that the professor has only surveyed physical education students. The person has done a convenient sample of his or her own students, but the person didn't get enough variety to actually make a conclusion about the entire population. And so yeah, if you take people from one convenient location, they'll probably be similar, and you won't get good insight into the entire population. Let's see. So I said, why would a researcher want to have a wide variety of population members? The last thing I was going to talk about is you really want something called a representative sample, which has the same mixture of people as the entire population. Some weeks we'll do more questions and some weeks we'll do less questions depending on how the time goes. Population of students is 20% engineering students. 20% social science. 30% business. So what do I have? 20, 20, 70. %10 English, and 20% law students. I think those add up to 100. A perfectly representative sample would need to include well, a perfectly representative sample of 100 well, the percents would have to match, so it would have to be 20%, meaning 20 engineering, 20 social science, 30 business, 10 10 English, and 20 law students. Now you see how my sample follows the same percentages as the population?
Mm-hmm.
20% of my 100 students are engineering, 20% are social science, 20 out of 100 is 20%, 30 out of 100 is 30%. So the reason I use 100 is because it's a nice number to use to get these nice numbers. You don't actually have to do any math. But this would be a perfect situation. You pretty much never actually get a perfectly representative sample, but the goal is to get us, in research, the goal is to get a sample that's as representative as possible. Because the more representative your sample is, the better information you get about the population. So more representativeness equals better information about the population. And more accurate conclusions. More accurate conclusions about the population. One analogy could be as if you have a cake with 3 layers. Vanilla, chocolate, and plain layers. If I cut a slice of the cake straight down like this would be a representative sample because my sample has 1/3 vanilla, 1/3 chocolate, and 1/3 plain, just like the entire cake does. And this representative sample here is going to give me a very good idea of what the cake tastes like. I'm going to get very accurate information about my population. So representative sample and good or accurate information about the cake.